So in question 1, we have two blocks, A and B. We have block A on the top of this ramp, which has a coefficient of friction. It's sliding down, colliding with block B, and then they will be stuck together, compressing the spring. And in part 1, we need to derive an expression for the speed of the block A at time t1, so just after it has come down the ramp. And we can consider the energy conservations. So it has an initial potential energy, and some of this energy will be used up by the friction, and the rest will be remaining kinetic energy over here. So the initial potential energy will be, we can say the mass of A times G, that's the weight, and then times D times the sine of theta, as this is the height that we need, which will be D times sine of theta. From this we will subtract the frictional force. So the frictional force will simply be equal to, we could split up the weight into these two components. So it has this vertical and this horizontal component, and then the frictional force will be equal to the horizontal component of the weight. Therefore this will be cosine. This theta shows up here as well, so this will simply be mu times ma times g, right? This is the normal force here, and we have to multiply it by cosine theta to get the correct component, and it will act through a distance d, and the work done by a force is the force times distance, and this will be equal to the kinetic energy of A at the bottom of the ramp. And then all we have to do now, we can divide by ma. And rearranging for v, we get there's the square root of 2gd sine theta minus mu cosine theta, just like this for part A1. And for part A2, we need to derive an expression for the spring constant k of the spring. And here we will have to use momentum conservation to find the final speed of their combined system, so that we can see how much kinetic energy that has. And we know that kinetic energy will be used to compress the spring by this distance. So we can say that before the collision we had 2mv momentum. After the collision we will have 3m times their combined speed momentum, and therefore VAB will simply be 2 over 3 2GD like this. And then their final kinetic energy. So their kinetic energy will be 1/2 times 3m times this VAB squared, which we have calculated. And this will be equal to the energy stored in the spring. So all we need to do now is rearrange for K. So K will be 3m over xc squared. We divide by this times 2 over 3 sine theta mu cosine theta, and all of this is squared. And so finally we get 8 over 3 mg d like this, divided by xc squared.